Okay, today what we're looking at again is a review of something you've done before, and that is the sine law. And so our goal today is I can use the sine law to solve angles and side lengths in non-right triangles. So what's different here is sine law can be used in triangles that do not contain a 90 degrees. So that's very useful for us. So the sine law. So first of all, there are two versions of the sine law. So the first thing that we look at is when we're labeling a triangle, what we're doing is the angle, we use capital letters, and the side directly opposite uses the lowercase letter of the angle. So that helps us determine what goes with what. So maybe you remember the sine law, two versions of it. One can be sine of angle A over side A is equal to the ratio of sine of B over side B over, which is equal to the sine of angle C over side C. So that's one version of it. The other version is just the whole thing flipped opposite, where I have the side length on the top and I have the angle on the bottom. Now remember, those capital letters, those are angles, and the only way to separate them is to actually take your calculator and find the sine of whatever the angle is. So you just can't separate the word sine when I'm solving something. Okay, so here we have now the few different things of when we can use the sine law. Obviously we can use them when we're talking about non-right triangles, so that's why it's useful to us. Now we can use it if we have the following. If we have two angles and any side. Well, let's face it, if I've given you two angles, that means you really have three, because you know that the sum of the interior angles of a triangle is 180 degrees. The other time that I can use it, when I have two sides and the angle opposite one of these sides. Now, I often don't look to see whether I have two sides, but one thing that I do really look at is if I know this side here, okay, I would need to know this angle here. So I need to know a side and its angle directly across. So I need that because if you look at what we're talking about solving ratios. Now the only way to solve a ratio is I would need to know something that's both on the top and on the bottom in order that when I cross multiply, I'm not left with too many unknowns. So let's take a look at a few hints that'll help you with this. So first of all, if you are given two angles, it just makes sense. Calculate the third one. Okay, you might need it, you might not, but if you've calculated it, then there's no problem. Also, just make sure, check, that you have an angle in its opposite side. So just like that picture that I showed you a moment ago. Okay, so let's actually go and do some questions here. Okay, so the first one says, solve for S. Now, when I look at this, it appears that I do not know a side and the angle directly across from it. Because if you notice, and I'll just do it with the magic pen, I have 53 is the only side length I have, which means it should go with angle R. Notice I don't know angle R. Does that mean that I rule out the sine law? No, because if you'll notice, I already have two angles. So it means I really can calculate that angle R, and then I can use the sine law. So that's why I suggested that you actually calculate all the angles that you can. So angle R equals 180 minus our 83 and our 26 for a grand total of 71 degrees. Now often I would put that back in here so it makes life a little bit easier. So I'm going to use the sine law. Now sine law uses A's and B's. My triangle has R's, S's, and T's. Does it really matter? Not really. Okay, so if we want to write this with R's and S's, we could do it the same way. So I'm going to use the sine law in this form right now. So over little r, sine of angle T over side T, and sine of S over little s. Now I probably don't need all three parts of the ratio, because first of all, I know my r's are going to go together. So I know I have sine of 71 over 53. And then t. Well, am I interested in t? Well, I don't know side t. and I don't know, have to find it, so I'm just going to leave it out completely. Now, if I look at S, I can see that I have 83, and I need to use it to find side S. So that's the first thing I'm going to do. So I have sine of 83 over little s. Now it's just a matter of cross multiplying and dividing. So really that skill is something that we use a lot in this course and actually in all math courses. So we have s sine of 71 equals 53 sine of 83. And to get s by itself, we divide both sides by the sine of 71. So I'll write that down as well. And I'm just going to bring my arrow over here so the person knows that that's where the rest of the work is found. And when I actually calculate that, I end up with 55.6, and the units are meters. Okay, make sure that you try those calculations with your own calculator to make sure that you know how to do it. Okay, the next question says find the measure of angle theta. So again, I'm looking to see angle theta is right here, and I can see that I have this side length and this angle. So I know I can use the sine law. My problem is I don't have, for angle theta, I don't know its side length. So I'm kind of stuck there. So what I'm going to do here is going to be very different from what we've been doing so far. Now I'm just going to see if I can blow this picture up in a minute so you can have a closer look. Okay, so what I'm looking at here is I'm going to use the 29 and 24, but I'm going to use this side length to calculate angle F. Once I have F, I can calculate theta, angle E, by subtracting the angle I'm going to find, and 29 to calculate E. Okay, now I'm just going to shrink that again. I think. And put it back in place. And so now we go and we write down our sine law again. So first of all, I'm going to find angle F. So what I'm doing is I'm writing that in my solution so that the people know, or whoever's looking at my work, or even myself if I go back, I know that the work I'm showing at the moment is to find angle F. So again, I'm going to use sine D over D equals sine F over F, and it's a matter of substituting my information in. So we have 29 degrees over 24.4, and sine of F over 38.2. Now when I do the calculation here for sine F, and obviously I'm probably writing too large in order for me to fit in my spaces I'm doing, but let's take a look. So sine F is going to equal the 38.2 times the sine of 29, and when I divide, I'm going to be dividing by 24.4. If you need the step before that, you just go right ahead and do it. So I end up with a decimal with decimal 7590. Now that's an awful small angle. Well, guess what? It's not the angle, it's actually just the ratio. So in order to find angle F, I have to do the sine inverse. And when we do that, we end up with approximately 49.4 degrees. Now remember, that's not what we were asked to find. We're actually asked to find theta. So we know that angle theta is equal to 180 minus the angle we just found and minus the 29 that we were given in the question. And we end up with 101.6 degrees. All right, so that one made us go through a few more hoops in order to solve. But again, the only way to do it was with the sine law. Now let's look at part B. Again, I'm asked to find theta, find an angle. The reason I can use the sine law is because I know 44 degrees and across from it is 29.5 centimeters. So again, I'm going to write down my formula. This time my triangle has A's and B's. I'm only interested in B and C, so I'm not even going to write down the A form of it. So what I'm going to do is I'm going to write the formula the opposite way, just so you can see that it works either way. and totally up to you which one you want to use, whether it's in this version of it or with the signs on the top. So this time if I look at B, directly across from B is 29.5 over the sine of 44. And we have 37.1 over the sine of C, or theta, depending on what you want to do. I think I'll put theta since they have theta in the diagram. Again, we're going to cross multiply, so we end up with 29.5 sine of theta equals 37.1 sine of 44. Sine theta is going to equal 37.1 sine 44 all over 29.5. Again, we end up with a decimal number because we actually have, oops, sorry about that, that's too close. We end up with the ratio of 8,736. So to find angle theta, we take the sine inverse of that lovely decimal for a grand total of 60.9 degrees. Okay, so that's a review of the sine law and a few different ways you can use it. You have fun practicing sine.